All right, so these are our first notes in Unit 3. Our goal today is, we have two goals. Calculate the measures of center. So that's the phrase, measures of center. We are familiar with all three of them, mean, median, and mode for data sets. And then the second goal is just using summation notation to express the mean, to express the thing that we already know how to do. So I'm going to start off with a couple definitions and, well, really one. A definition and then an example. So get your calculators ready. The mean. So our definition for mean, in case you forgot, is the sum of the observations divided by the number of observations. It's also known as the arithmetic mean or average. There's also a geometric mean, so just to distinguish here. Example is about weekly salaries. Can I get a volunteer to read about weekly salaries? Thank you, Philip.
Professor Hassett spent one summer working for a small mathematical consulting firm. The firm employed a few senior consultants who made between $800 and $1,050 per week. A few junior consultants who made between $400 and $450 per week, and several clerical workers who made $300 per week. The firm reported more employees during the first half of the summer than the second half. Tables 3.1, 3.2. This took a weekly earnings for the two halves of the summer fund mean of each of the two data sets.
Excellent, thank you. All right, so go ahead. I'm going to have this table right here and this table back here. You're going to find the mean for table 3.1. These two tables, find the mean for table 3.2. So everybody grab a calculator. When you have the mean, just use your buzzer to indicate you've got the mean. Thank you. For table 3.2, Emma. 474, excellent. So that was 4,740 divided by 10 was 474. For the peppermint. Heads up. Oh, that was, sorry. Teresa, for table 3.1, buzzing in.
483.
And how many cents?
0.84.
0.84, excellent. So we're talking about money here, so we can go to the nearest hundredth. And that was 6,290 divided by 13. Any questions? Anybody need further refresher on how to find the mean? 13, yep, that's a 13. We're putting these problems into actual contexts of real life scenarios, so it's good to be reminded, what do these numbers mean? So our interpretation is the employees who worked for the first half of the summer earned blank on average than those who worked in the second half. Anybody got it? Any guesses? What goes in the blank? You got this. Read over it one more time. Clover, you got it. They earned more dollars. That's it. All right, moving on. Introducing summation notation. We've already talked about that a little bit. The uppercase letter that looks like this. Sigma is shorthand for the sum. I gave you these cute little dotted lines from first grade so you could practice writing the symbol for summation notation. Write it down. Remember how we did this on Friday or Thursday? It's been a while since you learned a new symbol. Mine are kind of ugly, so I bet yours
Like cursive.
can be cuter. I don't know. It's a good question. I don't feel like I've ever seen cursive ancient Greek, but we can check into that. So
Can't be as bad as Russian cursive.
the letter sigma, practice again, corresponds to the uppercase letter, English letter S, used here means sounds a little redundant to the previous sentence. So for exam scores, we're going to calculate, first of all, the sum of the exam scores. So the way that we can, first it says use mathematical notation to represent the individual exam scores, and the way that we do that is we just do the X subscripts. So X sub 1 is how we read that, is 88. X sub 2 equals 75. X sub 3, I think you're catching on, is equal to what? 95. X sub 4 then would be A plus, 100. So does everybody see where I got those? Just using subscripts to represent.
I don't know why I wrote 55.
So we're going to use summation notation now to express the sum of the 4 exam scores. And the way that we can do that, use our summation symbol, and then we're going to write X sub I after it. I just means, don't worry, it's not imaginary numbers. This I just means an index. Index just means, hey, this value goes up, right? To the,
Time to elevate.
that's right, it means elevate. To whatever, however many values, however many observations you have. So in other words, in this case, this right here, this guy, little guy right here, means X sub 1 plus X sub 2 plus X sub 3 plus X sub 4. You can see why we just use X sub I, it's quicker.
So, quick question.
Yes.
So if there's an I, does that mean that they're using every X sub automatically?
All the X values, add up all the X values for that data set, yep. Teresa?
Does that then mean that they're all added together already, or?
It means to do that. So
It's like an instruction.
the answer, like this, ultimately equals whatever these are all added up. Who's got it? Who's got the sum?
358.
You got it. Nice job.
And that's all that means.
Yep, that's it. Learning to navigate Greek today.
Thanks.
You guys are so smart. Can I flip it? You guys ready? Okay. Next up, I'm just going to write in words what I just said out loud in case you're feeling foggy this morning. It's a little bit early. It's a Monday morning. So don't forget you have a reference in your notes. Subscripts do not necessarily indicate order, but rather provide a way of keeping the observations distinct. Has anybody done computer programming at all? Okay, good. So you're always using this type of thing to represent values that could change. We're just trying to represent our different X values from any observations using some subscripts. Google Sheets or Microsoft Excel is similar. It's like a programming language. So we'll talk more about Google Sheets and how that can help us shortly. So in place of X plus 1, or X sub 1 plus X sub 2 plus X sub 3 plus X sub 4, we can use summation notation read as X sub I, or the sum of the observations of the variable X. So for exam score data, the sum of X sub I is equal to what we just wrote. on the previous page. Just writing it in words. It's total repeat. The values of a variable for a sample from the population are called sample data. The mean of sample data is called a sample mean. Y'all are on it. Somebody had their coffee this morning. Or water. Water actually helps wake you up too. Sample mean for variable x, the mean of the observations for a sample, see the emphasis here on sample, is called the sample mean. It's denoted, what? X bar. It's denoted by X bar. Boom. Put a square around this guy, put a star too. X bar is equal to the sum of all the x values divided by n. What's n, you say?
It's a numerator.
N is a number. It's the number. It's the sample size. So you're gonna get, that says size. That word right there is size, okay? That's a Z. It went a little crazy. Sample size. You're gonna ask me later, what does N mean? Here it is. Don't forget about N. N means something. What does N mean?
No.
Thanks for keeping it light. All right, why don't you read it about children of diabetic mothers. Kylan, thanks. Just skip the stuff in parentheses.
Okay, the paper,
Skip that part.
yeah, so
That paper,
just continue.
just start here.
Okay.
Presented findings.
Of research on children of diabetic mothers. Past studies show that maternal diabetes results in obesity, blood pressure, and glucose tolerant complications in the offspring. Continuing. Table 3.5 presents the arterial blood pressures in millimeters of mercury, mmHg, for a sample of 16 children of diabetic mothers. Determine the sample mean of these arterial blood pressures.
Well done. You had some tough words in there. You skipped some of them, but you nailed some of them. So, good job. What the sample mean of all these arterial blood pressures? Who's been already calculating? Has anybody been on the calculator already? Typing those in, adding those up. Here's what I want you to do. I want you to rewrite the formula because you haven't written it out, actually. I wrote it for you. So I want you to write x bar equals the sum of all the x values divided by n. On your notes, on your paper. Just practice writing that out because when you write it, your brain makes a new connection than when you just hear it or see it.
So I have a question for you. So, if the E, the X and the I represent the sum of all the X, what do you call it?
X values, observations. Mm-hmm.
And then the N is is it number or is it sample?
The N?
Yeah,
What does N mean again?
I don't know. Sample size.
Yes. Mm-hmm.
Sample size. Now what does X bar represent?
X bar,
Does it just represent the entire number?
it's the whole thing. Mm-hmm. Yep. Clover.
I got, you want to shoot the whole thing?
Yeah, sure.
86.40625.
Okay, 86.405?
406.
So 406? Did anybody get something different?
I probably missed something.
What did you get?
I can't remember, so.
Oh, wait, hang on.
What did she get?
86.4.
6.4?
I don't, what did you get?
1.8.
Yeah, that's what I got.
Okay.
So we were close. 86.2, that's what I got. So close. Well done. 86.2. 1,378.9 was my sum of all the observations, sum of all the samples.
How do we get that?
We added these together. How did we get this number? We added. That's for you guys. Does that help answer your question?
So you just add all these together and then you're like, number.
We added, this symbol here means add all the observations together.
Then why don't we, okay.
And then we divided by how many there were. We just found the mean.
So it's literally the average.
It's the average. As we stated up here, the sample mean. We just have new notation for it.
Yes, ma'am.
Median. Think about the middle of the road is called the median. For all of you drivers out there. Arrange the data in increasing order. These are the steps. Steps can be helpful if we forget how to find the median. Don't forget the first step. In your Math Excel assignment, they're not always in order. So if the number of observations is odd, then the median is the observation exactly in the middle. We saw this in our example with song lengths of Beatles songs on the album Help on Thursday. Middle, right in the middle. But if the number of observations is even, then the median is the mean of the two middle observations. So it just depends if there's an even or odd number of observations. In both cases, if we let n denote the number of observations, oh look, we're just repeating ourselves, then the mean is at the position n plus 1 divided by 2. It's not how you calculate the median, it's the position of the median. For example, let's take a look. I hole punched out, apparently, a number here. This number here was 300. Just one number is hole punched out. Can I? I'll do it later. So for this data set, it's the same one from the front of earnings in the summer, first half. So we have 3, 6, 9, 12, 13 observations. It happens. Just set it on the, you can just set it, yeah, it's okay. Mrs. Money will fix it. This is the comic relief of our video notes. People don't know what happened. It'll be a mystery. All right, so for table 3.1, if we're calculating the position when n is equal to 13, remember, number of observations is 13, my median will be located, my position of the median is going to be at 13 plus 1 divided by 2. Maybe I can zoom in for you.
How do you drive?
So the seventh number, when I write them in order from least to greatest, will be my median.
What is a
They
TBL?
figured this out, was like, no matter what, this is gonna be the answer.
Oh, table.
What?
I was like, what is TBL? It's freaking table.
That's right, you got it. So if I write these in order, I'm gonna real quick do that. 300, 300, help me out. What's next? Yep, 300.
450, oh, okay, no, you got that. Keep going.
Oh, wow, there's like 5.
There are 6 300s. A lot of people earning $300 a week. 400, thank you. Thank you. Uh-huh. That's why we're really small. 800, then what?
940,
Uh-huh.
1,050.
Thank you. Killing it over there. All right, so I know I could do this little game. Honestly, the older I get, the harder this game gets. Where I go boom, 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 boom. You know the median game, like, okay. And it's fine, although these data sets that we do in our notes are arbitrarily small. Most data sets are a lot bigger. So doing that game gets harder and harder. So this position formula comes in handy. All I have to do is count to the seventh one, 3, 4, 5, 6, 7. I arrived at 400.
That's great.
Take my word for it, it's easier than doing the median game.
I need a person who's a mathematician who found that.
You want to thank them? Me too. It's a game changer, especially when you put a data set into Google Sheets and you line them all up.
Yep.
And then all you have to do is look for the number 13 or 7 or whatever it is, the middle. Boom. Okay, we should probably practice that one more time with this other data set because there are an even number of data points. There's 10 data points in this set, but I'm running out of space, so I'm going to use this little note card. You can use your table. I do want us to practice it together because you'll have an even number of data points in your notes or in your assignment tonight. Let's put these in order. But first, let's say table 3.2, and how many values are there? We said that already. 10, thank you. I just feel like you're listening when you can respond to those easy questions. So n is 10, so that means 10 plus 1 divided by 2, 11 divided by 2 is 5.5. Our median in this case will be right between the fifth and sixth observation, okay? So write them all out in order. 300, then what? There's 6, 2, 3, 4, 5. Okay, then what? 2 400s? Then what? Wait, I skipped over. 450, okay, then what? Ah! What's next? Thank you. Oh, man, I was close to the edge there. All right. 1, 2, 3, 4, 5, 6. Halfway between those two is 3. Well, you probably could just do that in your head, but for the sake of practicing finding the mean of the two middle numbers, 300 plus 400 divided by 2 is 700. Divided by 2 is 350. Median is 350. Boom. For wherever you wrote that down, feeling good about it?
Yes, ma'am.
No more complications. I know median, sometimes we freak out and we go, oh gosh, what if there's an even or odd number? And now we have simplified the whole thing with this special little position formula. Yeah, I'll give you my, here. 700. I know it's an ugly 700 also, yes. That's okay. It's harder when you can't see. That's okay. And now for the breakdown. Did you ever wonder, but which one's best? Mean, median, or mode? For determining the measure of center? I know you've been wondering this for quite some time. I'm about to solve the problem for you. The mean is not immune, okay? That's what goes in this blank. It's not immune, and neither are you. It's not immune to extreme, very large, or very small observations. So if we have those outliers, like we do when we have a right-skewed data set or a left-skewed data set, you got those outliers, it really impacts the mean. The mean doesn't represent the middle as well in those cases. So the median is immune. I kept the wrong word there. Unfortunately, you're going to have to cross that out. It is immune to the extremes. So, therefore, you know this is going to come up on Math Excel. You know it. Therefore, the median is preferred for data sets that have extreme observations. I'm going to pause. I'm going to ask somebody to repeat that very same thing that I just read out loud. Bella?
Bella.
I was listening, but it's Nick.
You can just read it off your paper right here.
Oh, that?
Uh-huh.
Therefore, the median is
Uh-huh.
The median is preferred for data sets that have extreme observation.
Yes, give it up for Bella. Good job, Bella. I want you to take 20 seconds and talk to the people at your table to process what we just said there between the mean and the median, and which one's preferred when.
The median is preferred when, you're doing data that are extreme. So the point of the mean, no, they're asking, never mind. Why?
All right, your 20 seconds is up. Hopefully you have, when you're able to speak about it, talk about it. Does anybody have a way to reword that? I heard somebody in a scary voice talking about it up front. Maybe somebody not in a scary voice. Just kidding. You can share it in a scary voice if you feel. It's Monday. We feel the Mondays.
I think that the median is more preferred for, extreme data sets.
I like
That
it.
was about it.
Thanks. What's that?
Is this going on YouTube?
Mhm, yeah. All 26 and counting minutes of it, yes. The mode is the one that occurs the most often. So you start with finding the frequency of each value in the data set. If no value occurs more than once, guess what? No mode. Otherwise, any value that occurs with the greatest frequency is a mode of the data set. I like the mode. I feel real comfortable with the mode. It's pretty easy, straightforward. Determine the modes of each of the two data sets of salary data given in tables 3.1 and 3.2. 3.1 and 3.2 are the same mode. What is it? $300. Okay, that was obvious. We wrote it down lots of times. This way or this way? Which way? This way? Okay. We're going to talk about using technology to calculate the mean and the median of data sets. We can do that in Google Sheets. I'm going to give you a note to write down. Everybody should write this down. When we're in Google Sheets, I'm going to specify here, in Google Sheets. It's hard because I'm trying to zoom in. Okay, are we good here? Okay, thanks a lot. You're going to type in, after you type in all the numbers, you're going to type in equals, remember that's the thing that accesses a function, equals average. And then you're going to open parentheses, you're going to put a cell, okay, such as like A1. I'm just putting these in for example. It changes depending on your data set to maybe you have 10 data points like we do in table 3.2 to A10. That's what you would type into the cell underneath all of your 10 observations. And we'll look at an example in a second. It's hard to do technology stuff while I'm doing my paper notes. Last one, and similarly in Google Sheets, we'll type in equals median for that one. Pretty straightforward. And A1 colon A10 or whatever those values may be. You can always put them in order and do our trick, n plus 1 divided by 2, and just find the position, or you can use this function, which is just a little quicker. That concludes our notes for 3.1.
Toodaloo.
Notes, measures of center.